we'll discuss about some theoretical concept here. Some theoretical concept. After the HANA administration, we have the some theoretical concept we should discuss about the here. So we'll discuss about those things. These are the very important. These are the very important. So agenda for today topic is called the delta merge concept. Delta merge concept and save point. Save point. These are the very important. Delta merge and save points are very important here. So these are the internal mechanisms in the HANA database. These are the internal mechanisms in the HANA database. So it will run internally. You don't need to execute anything here. It will run internally here. That is called the delta merge save point. So what does it mean by delta merge and save point here in the HANA database? So it's a very important. So you can see this is the our HANA data. This is the our operating system, right? In the operating system, see here. So every table's data, it will store into the main memory, right? Every table data, it will store into the main memory. This is the called the RAM memory. You can say like in memory. Okay. I can say like this is the in memory RAM memory. And also we have the file systems are available. OS level, we have the file systems, right? OS level, we have the one copy of file systems are available here. That is called the /HANA data and /HANA log folder here. /HANA data and /HANA log folder here. This is the RAM memory here. Normally, what we discussed in the HANA administration side, HANA is a in-memory database platform, which means if any data coming to the HANA database, this is the HANA. Okay, this is the SAP HANA database. If any data which is coming inside of the HANA database, so that will store into the in-memory only, right? That we know, everybody knows. So everybody knows HANA is the in-memory platform here. It won't directly go to the RAM memory. This is the file systems. This is the storage or file systems. In the Linux level, we will call it the file systems or storage. So this is the in-memory platform here. This is the in-memory platform here. In the in-memory platform here, what's happening here in the in-memory platform? So as we know, only we know data will be stored in the in-memory itself. But in the in-memory itself, there the two memory areas are there. Means the RAM memory basically is divided into the two memory areas here. Two memory areas here. One is the DS. So one is the delta storage. One is the delta storage here. Second one is the main storage here. Second one is the main storage here. Delta storage and main storage here. So every table, they have the two memory storages here. Delta storage and main storage here. Delta storage and every main storage in the RAM memory here. So if any data which is coming to the here means it will store the first of all that should be execute, right? The query or the data should execute it here. So all the queries, all the data, it will execute in the delta storage itself only. Delta storage itself only. So why? Because the main storage, the main memory is divided into the two parts here, DS and MS. So main storage and delta storage here. So all the query statements, first it will execute into the all the statements and queries, the first it will execute into the delta storage itself. So then why? Because the delta storage is so read plus write plus the compression factor will be applied here. But the main storage only read and the compression mechanism will be applied here. So the users or data cannot directly store into the execute into the main storage here. The first it will execute into the delta storage. Suppose you are trying to book the ticket, you are trying to do the some payments. So first it will be execution, everything will happen in the delta storage itself. Why? Because delta storage read optimized and write optimized and its compression factor. So it will be compressed, the data will be compressed here. So which means you can only directly write the data into the delta storage here. Sir, why can't I write the data into the main storage here? Why means the main storage operations are very costly. Why? Because already committed transactions, committed data, already completed data, committed data, already there in the main storage, already there in the main storage. If the new transaction also executing the same in the main storage, what will happen? So the existing data may be corrupt, the existing transactions may be corrupted. So to avoid this clashes, SAP think and they have introduced the delta storage concept here. So you, instead of directly hitting the main storage, and first of all you execute in the delta storage here. Once you done the transaction, once your transaction is committed, then the data will be moved to the main storage. The data will be moved to the main storage here. And when it will be moved to the main storage, if the transaction is committed, then data will be moved to main storage here. So these operations are called the delta merge operation. So whatever there in the delta, that delta is merging into the main storage. That delta is merging into the main storage here. So here the main storage we cannot sorry. So we cannot directly write anything into the main storage. Why? Because main storage operations are very costly or very important here. So if you directly write it, while writing, if there is any problem, then existing data also impacted. To avoid this one, any transactions or anything will be executed in the delta storage. Then once you done with the ticket booking or the transaction is completed, then the data will be moved to the main storage. The data will be moved to the main storage. So this operation is called the delta merge operations. So moving the data from delta storage to main storage is called the delta merge operation. Merging the data. So main storage merging the data with the delta storage data. That is called the main delta merge operation. Delta merge operation here. So this will happen when the current transaction is completed. Suppose I opened the IRCTC, then I am booking the one ticket here now. So I opened the IRCTC. So I am booking the one ticket now, right? I am booking the, maybe let me try to book one ticket here, not a real ticket, whatever it may be. Okay, just I'm booking the one ticket here. I'm just checking the ticket status. Everything it is getting the full from the your database level. The operations are, everything is coming the database level itself here. So then I'm going to book the ticket now. So I'm going to book the ticket now. I will log in. I will book the ticket. Once my transaction is successfully completed, before that itself, you are booking the ticket, you have opened the screen, log on screen, everything will happen in the delta storage itself only. If you are booking, once your transaction is committed, once your transaction is completed, then the data will be moved to the main storage. The data will be moved to the main storage itself. This is called the, once the transaction is booked, what will happen? Your transaction has been successfully completed. This is your seat number, waiting list, something like that. You will get all those information, right? So that once you got that information, your committed data, your transactions data will go to the main storage. This is called the here delta merge operation. Once the data moved to the main storage, then after the 5 minutes, automatically the same data will be go to the your data folder after 5 minutes. Every save point. This is called the save point mechanism. Save point. This will happen every 5 minutes once. Internally, these are all the internal mechanisms here. Every 5 minutes, the save point will happen. The data will be moved from the main storage to the and your file system data folder level. It will move from here to here. This mechanism is called the save point mechanism. This will happen every 5 minutes once. This will happen in every 5 minutes once. It will happen here. So that's why. So we have this concept. That's why we have this concept is called the save point mechanism. Okay. That's why we have this mechanism called the save point mechanism. So why? Because why one copy of data storing into the here in the file system itself? Why? Because data is storing into the here main memory means that is fine. That is the HANA mechanism, internal mechanism. So why one more copy of data storing into the file system means so RAM operations are RAM is volatile memory. The RAM is volatile. Volatile memory means temporary memory only. Temporary memory only. So which means whenever any restarts, something hardware failures are happened, whatever the data is there in the RAM, all the data gone. All the data gone. It's come to the zero status here. It will come to the zero status here. We have already tested this one, right? So now, then what happens in this case? What happens in this case? So whenever you restart, data is available every 5 minutes. The data is coming to the data folder, right? So one copy of data is available in the data folder. Whatever the data is there here, same data structure is available here. So what will happen here? Whenever you start the HANA database, using the HDB start command, so what will happen? It will take the some time, which means whatever data is there here, same data will be reloaded back to the your main storage, reloaded back to the your main storage here, reloaded back to the your main storage. So that is the reason how much data is there here, same data will be loaded to the here. So this will happen in the when you are starting the HANA database. When you are starting the HANA database, so all the data will be reloaded to your main storage. Why? Because before reloading, you are stopped the HANA system. Then all the data will be gone, right? Zero, HANA zero. Then when you are starting the HANA database, it will come to the again same status here. We already seen stopping and starting procedure. We already have experience, right? So otherwise, let me see now here. Our RAM size is 30 GB used now. Okay, let me go to stop the one database here. I will stop the H4C medium. I will stop it here. Okay, so let's see how much data will be reduced here. So 30 GB now. Used is the 30 GB now, right? So now I'm stopping the HANA database. When you are stopping the HANA database, what will happen here? Whatever the data is there, the 30 GB data will be loaded to the your OS level file system. There is a /HANA data is there, right? It will be loaded. It will be reloaded actually. It will be loaded to the your 30 GB, thereby it will be loaded. Now I stopped here. Now you check the memory status here. See here, it's decreased to the 15 GB, almost 15 GB data, 14 GB data got decreased. Means the RAM usage got decreased here. Means only this H4C using the 14 GB data is available in the RAM memory. 14 GB data is available in the RAM memory here. We have the HD5 also. If you stop HDB5 also, some amount of data get reduced from here also, right? So that is the concept here. When you are starting, let me start the HANA H4C again. Okay, let me start the H4C again now. So now what will happen when you are starting? Whatever the data is there, all the data will be reloaded. All the data will be reloaded to main memory now. all the data will be again reloaded to main memory now. So this will happen now. See here, it is giving here. Sir, where can we check whether it is reloading or not? In the, so here, all these mechanisms, we can track it at operating system level. This delta storage, save point mechanism, all these one, we can track it. We can track it here. That will, in the log files, we can track it whether it's happening or not. That I will show you. See here, why it is taking longer duration? Why it is taking longer duration means while starting, the data, how much data is there, all the data should be loaded to the here. Then it will go to the completed started status here. Let's see, let's wait for some time. Let's still starting now. Here, how much time it is taking? 14 GB data should be loaded to the main memory. So it should take some time to load the data here. So while it is loading, we can monitor it here. While loading, so we can monitor, we can see how many tables are loading and what is the data it is getting loaded. All the information will be tracked here. So if you go to the H4C ADM, then CD trace the OS level file system here. OS level, the file system here. Here you can see the loads, right? Just if you open this loads, data will be loaded here. The data will be loaded here. See here, what are the tables are getting loaded. All the applications are getting loaded. What are the tables? All the information will be loaded here. All the, see here, the data is loading, still loading. You see here is getting loaded. Now I put my cursor here, you see. The data is getting updated here. See here, right? So it is updating. You are updating the data here. So finally it started here. Then -G, again it will come to the, so 20%, 20 GB here. So which means here it is using the, it is using the same, it is using the same here. So it is using the same. So it is using the memory, means all the data again will be loaded to the your main memory here. All the data will be loaded to the main memory here. All the data will be loaded to the main memory here. So this is the very important here, right? So that is the, this mechanism is called the save point mechanism. Every 5 minutes, the data will be written to the data folder here. The data will be written into the here. The data will be written into the your data folder here. Then so it will write that the first data will comes to the here. Then after that it will go to the main storage. Then after 5 minutes, it will same data will copy the to the data folder here. In case of anything happens, again the data will be reloaded to the main storage here. The main storage here. So this is called the delta merge and save point operations. Delta merge and save point operations. Okay. So any questions from anyone regarding these two concepts? So now let's talk about the OS level file system here, right? After this concepts completed, now we have the OS level file systems here. So how we have the USR, SCP, SID, we have the here also we have the HANA file systems. HANA file systems here. Here, so we have USR, SAP, SID. This is also will create the one SID here. Then sys folder it will create it. Then HDB instance number. So then how it will create it here? Same way here also it will create the sys and instance folder. SAP also it will create the USR, SAP, SID, USR, SAP, SID here. USR, SAP, SID. Then after that, USR, SAP, SID here. Then we have sys folder, then here HDB instance number, right? So same way SAP also same file system will be created. Here also in the HANA, if you go to the HANA database here, so see here CD slash USR SAP here. Under the USR SAP, we will come to know how many SIDs are there here. See how many SIDs are there here. Our guys are installed here. How many SIDs our guys are installed here. Then go to CD slash HD7. CD slash HD7. Our database is HD7, right? I went to the HD7 here. USR, SAP, SID. Then LS-LTR. Here, you see here, sys and HDB instance number here. Same. When you go to the SAP here, I'm comparing both USR, SAP, SID. Under the SID, we have the sys D instance number, ASS instance number here. But this is a database, right? So here only we will get the sys, then D instance number, DBB instance number, which means here this is the D dialog instances. So here it is the HANA databases. HANA databases means HDB. HDB instance number one folder is created. So then go to the CD sys here. Under the CD sys, here you have the same profile directory, global directory, executable files. Same, if we go to the sys, here we have the exe, all the executable files are there here. These are the SAP related executable files, right? So here in the HANA also we have, in the HANA also we have the CD exe. Then if we go to the here HDB, here we have the all the executable files are there, binaries here. So compile server, name server. So if the compile server is running, name server is running successfully, means because of the binaries are exist, the library files are exist at operating system level. So because of this reason, your binaries are up, binaries means your HANA is working, running fine. So this is the heart for the HANA database, this file system. If the exe folder is not there, deleted, your HANA it won't start. Same as like here, SAP also, there is no exe folder. What will happen? Your SAP, it won't start or immediately it will go down here. Here in the global directory, we have some security settings. Here also here, this global here. In the global directory here, in the sys global, so we have some security settings and CD. Here, this path is very important. CD, HDB, custom, config. So here we have the INI files are available here. INI files are available. INI files are available. INI files are available. So INI files. INI files means we know, right? Yesterday in the configuration tab, we'll see the files. INI files, diamond.ini, global.ini, index server.ini, name server.ini. How the INI files are there? Operating system level, all the INI files are located in this location. In this location, this is the path. So if the interviewer asking the question, means this is the path here. This is the path interviewer is asking the questions here. Okay, so remember this path here. Okay, this is the very, very important path here, where the INI files will be stored at operating system level. So which means, so USR, SAP, SID, sys global HDB custom config location. So custom config location in this location. Okay. Okay, so someone remove that headline. Some red mark. Someone copied this one. Vivo 2118. Just erase it from your side, your screen. Okay. Thank you. Again. Okay. So it's there. This is the very important here. So this one, just you can take a note down. Nothing, no one will ask any questions on this one. This is the very important question here. Okay, that will be available in the global directory. Profiles means HANA related instance profile, default profile. That we won't change anything here. Only we will change the INA files in the configuration settings in the HANA Studio. Here we will change it, or we can go to the HDB custom config. Here we will change the files here. This is about the file system structure here in the sys folder here under the sys. If we go back under the sys, we have the three folders, exe global profile directory here. If we go back here, HD7 07. So here you see, so under the SID, we have again exe, same, right? So then these all are the environmental variables, you can ignore it. Then backup folder, backups, it will run in this location. Work directory, so it's a work related directory. This is not important. So here, very important folder is this is the one, instance number, host name, after the host name, cd trace directory. In the in the SAP level, in the SAP level, how we have this work directory, the instance number, work directory, how it is that much of important here to troubleshoot the logs in the HANA level. So this trace directory is very important here. This is available. Sometimes they may ask you, can you tell me the location of the trace directory? So USR, SAP, SAD, HDB, instance number, and host name. What is your host name? The host name will come. Host name / trace. This is the trace file for here. Under the trace, we have the name server, daemon, so compile server, access engine, web dispatcher, all will be available here. Suppose if any issues with the name server, if any issues with the compile server, so all those things we can check from here. This is the one. So if any tenant means suppose HD7, right? So suppose you want to check the HD tenant, then go to the HD7 in this tenant folder. We can see the tenant means only index server, access engine is available here. Index server, access engine is available. So we can check the index server, access engine related log files. We can see it here. Index server, access engine related log files here. Index server is the main file here. So all the data will reside here. Here we can monitor all the information, what is happening with my index server. Okay. So here you can see here. So what is the current version of the save point? As I told you, right? Save point. Every 5 minutes, the save point will happen. It will load the data here, right? So here you can see the save point version here, right? The save point version here. So here the 11:29 one save point happened, right? After the 5 minutes again 11:34. Now 11:39 one more save point is happened here, right? 11:34 here. Then 11:43 one more save point will happen now here. 43, right? 5 means 44, right? 44, 11:44 one more save point will happen. So which means every 5 minutes, whatever the data is there here, so in the RAM memory, the data will be loaded to your data folder, here. That data folder that will be loaded to your data folder here. So that is the save point mechanism here. Here in the trace directory, in the index server trace file, we can see the log files here. In the index server trace directory, we can see the log files here, how it is behaving. So all the information we can see it here. All the information we can see it here, right? So that is the very important. Any errors? About see here, unsupported file system type here, unsupported file system type here. So all the information is getting recorded. So this is the very important file system is the trace directory. Any errors, HANA database level, any performance issues, any slowness, high memory usage, anything, just you need to come to the index server trace file. You need to open and see what's happening. You need to see what's happening with the by this one. What's happening with the my this one. It will display the clear information. It will display the clear information here. Okay, this is the index server trace file. This is the index server trace file here. Okay, so all the information, whatever happening in the database level. So why? Because index server is the main here for us, right? Why? Because all the data will resides in the index server. So when you are starting, if you see the index server loads file, how many tables are getting loaded? When you are stopping, that time this will be unloaded. This will be unloaded here. All will be displayed here. All the data will be displayed here. All the data will be displayed in the index server trace file. If any issues, how for SAP level, how we will go to the work directory, we will see the all the logs, work process logs and everything here. In the database level, if any issues, we need to come to the trace directory. We can see the tenant specific log files. We can see it here, right? Up to trace, we can see the system DB files. Within that system DB, we have the tenant related DB underscore HD7, some other tenant related. That tenant related files, we can see it here. The tenant related files, we can see it here. Log files, we can see it here, right? These are the same log files will be displayed here in the diagnosis files as well. In the diagnosis file, same information, same trace files here. If it is the tenant, if you go to the diagnosis files, same information will be displayed here. Same information is displaying index server trace, access engine trace, loads, unloads, same information is displaying here. Same information is displaying here. So these file systems are very important here. These file systems are very important here. These file systems are very important here for to monitor, to track the issues and everything here. So that is the very important here. Okay, so that is the very important here. Okay, so any questions regarding these file systems? This is the file systems, very important. This is the one part, and the second one is the where are the INI files are located. These two common questions they may ask you each and every interview point of time. These two questions they may ask you each and every password here. Okay, any questions from anyone? Is it clear?
So Savepoint is 5 minutes for every system, sir?
Yeah, every system, every HANA system. So Savepoint is here.
5 minutes only.
We can increase it. If we increase it, so within that after 5 minutes something is happened again, we have the data loss. So that's why to avoid it, the SAP recommendation is every 5 minutes the save point will happen here. Every save point, the save point will happen here. That is the very important thing here. So every 5 minutes the save point will happen. Here we can monitor it here. So from here we can see the save point. What is the current 44? It is happened. Before that 39, 34, 29. So then, so 29, 24, 11, 24, like that. To see here, the save points are happening here. If any errors also, we can monitor it here. So unsupported file systems, error messages. So this all we can monitor from the here itself. So in the diagnosis files, we can monitor. Otherwise, OS level trace directory. The OS level trace directory also we can monitor from here. That is the one thing here we can see, right? So please check the file system space and check the monitor the logs here. Your tenant is important. So If you just find out the index server trace file, you will get the all the information, what is happening with the my tenant, and all the information you will get from here, right? So just check the tenant related information here. That's it. So these are the important questions they may ask you. So what is the save point? What is the delta match? How to check the where the INA files are located at the operating system level. So then, so the next one is the trace. If any issues with the HANA database, normally you cannot check from here, right? You cannot check from the HANA Studio. Then where can you check here? In the operating system level, so we have the trace directory. We can go to the trace directory. We can check it out. Like that, we can answer it. So sometimes we may go, can you tell me the complete location of the trace directory? Then in this case, you have to tell like USR, SAP, SID, then HDB instance number, then host name / trace. Like that, we have to answer. Right? These are the important things here. Is it clear? Then,
Yes.
once you clear with this one, so tomorrow I will explain about so what are these tabs here? What is this content here? What are those provisioning? What are the HANA security? Then HANA backups, restore, recovery, the many things are there. So we'll go over one by one here. So for now, today, you can just to read these concepts and also just to familiarize with your Linux commands to go to the inside of the file system and check the logs and everything here. To view the file content, we need to use the more or tail command or the cat command. So these commands we discussed. So we can use these commands to familiarize, right? So just go with just see the logs, what's happening with the HANA database, what logs are storing here. So check all those information. Okay. So here the timeout is occurred here. Sometime maybe some timeout occurred here. What is this timeout here? So index server, the port that throws the exception. What is this? You need to check this error messages. So like this, we need to, so memory resources, I guess. So we need to, like this, we need to check the log files here. First of all, try to read the log file. What is happening with the my system? So if you get familiar with the reading the log files, then you can troubleshoot the any issue here, right? So you need to find out what is happening in the log file. You need to find out what is happening. So what's are the issues we have here? If any issues, it will throw the dump here in the log. Symptoms will be shown in the log messages here. So the trace directory is very important here. Okay. So try to practice this operating system level commands and this one. So tomorrow we'll discuss with more on the other topics. Okay.